All right, good morning. It looks like my audio is on. Welcome back. We are here for the second session of the Educa IPv6-Only day. This session will be touching on IPv6-Only data centers. You saw me all of 2 minutes ago. My name is Stephen and I'm your moderator for now. We have Iljitsch van Beijnum talking about address planning, followed by Tori Anderson talking about SIIT-DC for v6 only, followed by Pete Stevens on managing IPv6 only services on the Raspberry Pi cloud. If you've been anywhere near the v6 community for any length of time, you've heard of all of these names, so I trust that we have some good talks coming up. The chat is available to you. If people put questions into the Q&A, then I will try and follow up for each presenter as we go through, rather than holding them all till the end. Iljitsch, I think the floor is yours.
Thank you. Okay, let's talk about some IPv6 planning, address planning. Okay, make it. So this is the organization of my talk. If you download the presentation, everything is clickable, but not here. Of course, if you want to do address planning, you need to learn hexadecimal. I'm not going to explain that today, but we have Wikipedia for that. So the first thing I want to talk about is why it is important to do address planning. Well, the simple thing is that if you are going to use IPv6, then at some point you need to think about how you are going to plan your addressing. So the only question is, do you do that beforehand, or do you do that when you already have something that you didn't think about and then have to go back and redo it? So maybe you'll end up making multiple address plans until you have the perfect one. Of course, perfect would be good, but IPv6 will be around for a very long time. So it's hard to predict the future. So you will end up in a situation where you think, I would have preferred to have done this differently. So you have to prepare to adjust. The good thing is that we have insane amounts of address space in IPv6. So get rid of IPv4 thinking and just make everything way too big. There is no excuse for making stuff too small and running out of address space and having to renumber. That doesn't make any sense. Also, even making small changes is very annoying and very hard. So basically, if you need to make a small change, it's not worth it. So basically, you're only going to make big changes and prepare for that. One thing you could do is, if you're not really sure about the way you want to deploy IPv6, is just build a test setup where you can do some limited testing. It needs to be something that is close to production, not just a lab test. That's not good enough. But then you have to have the discipline to throw away the test setup and make a new plan and build everything up for real production according to the new plan. Rather than have a bad test setup and just keep growing it, because that doesn't work. It's important to realize that there's different types of IPv6 addresses. We have linked local addresses. Those are created automatically, and routing protocols, other low-level stuff uses those, and stay away from them. Don't put them in the DNS. Don't put them in your applications. They will be used when they are needed, but leave them alone. Don't try to manage them yourself. Then there is, of course, global unicast. That's what we call regular IPv6 addresses. Those are the ones you are going to use almost all the time. But in a few situations, you might want to use unique site local addresses. Those are very similar to RFC 1918 addresses in IPv4. But there's two big differences. That is, we have no net in IPv6, no network address translation. So these addresses will never be usable on the internet, unlike RFC 1918 addresses, which are usually translated at some point. And they are unique. So everybody has their own set of these local addresses, So when you have two organizations that merge their networks, those won't overlap, unlike RFC 1918 addresses, which is a big headache in the enterprise world. Assignment size. What is the address block you are going to get that you need to plan for? Well, basically, if you are an end user and you have a consumer connection, then it might be something small, /56/60, or even single /64. But for anything that is bigger than a home user, a consumer, then you should really get a /48. That's the standard size. Even if you don't need much, it's just so much easier to just use /48. And we do have enough IPv6 addresses to give everybody their own /48. We are not going to run out. What that means is that the first 48 bits are given. There are, of course, 128 bits in the IPv6 address. That means the remaining 80 bits you get to fill in yourself. So that is what we are going to do with our address plan. One other thing about /48, that is the smallest block you can have routed over the internet in BGP. So if you want to have your own provider-independent addresses that you can take with you when you move to another ISP, it needs to be at least /48, otherwise that's not going to work. So what we don't want to do is get /48, 80 bits left, and just start numbering everything as one huge network with those 80 bits. We are going to subnet. We are going to split our own network into different subnetworks, a number of these, and then we of course have to think about the subnet part and the local part. So this is what an IPv6 address can look like, two versions. If you don't understand this notation, there's an RFC that explains it. It's not with all kinds of technical protocol details, it just talks about how the addresses look like in IPv6. Okay, so we have the 48 bits are given to us. Then the thing is, 64 bits are needed to do local numbering of devices. That gives us 16 bits for the subnets, like this. So the first 48 bits are, they come from the Internet Assigned Numbers Authority, the regional internet registries like the RIPE NCC and ISPs. So don't worry about that. You just get 48 bits that are given. You can change them. And then you have the 16 subnet bits. And then the last half of the address is the host part, the local part. Okay, so how do we plan the subnet bits, or why should we have subnet bits? That is, for instance, if you have two locations, the routers need to send packets to the right location. If you have one huge subnet that has these two locations, then the routers can make a good routing decision. They need to have a view of where actually stuff needs to go. So you can only have, if you want to avoid trouble and you want to give your routers a break, you only want to have a subnet span one location. Also, there is the whole thing, if you put too much stuff in one subnet, you get big broadcast domains and failure domains. So you want to keep that to a reasonable size. For instance, in an office building, usually one subnet per floor, or a data center. If you have top of rack switches, then it is useful to have one subnet for every rack. So this one switch knows how to handle that. You don't have to do complex stuff. Then there's also security. For instance, if you have a guest network, which is pretty common these days, you don't really want to have that be the same subnet as your back-end servers. So guest stuff, workstations, front-end servers, back-end servers, that's a fairly logical way to divide this up in different usage types or security levels. There's usually more, but these are a few obvious ones. Did I click here? Okay, so one very easy way to create your subnet divisions is if you already have a network that has VLANs with VLAN IDs. You just take the VLAN ID, you just put it in the subnet part of the IPv6 address, and you're done. So you can enjoy the afternoon. You can go home early if you do that. Of course, it helps if your VLAN numbering makes any sense, because if it's fairly random, then your IPv6 numbering will also be fairly random, which is not always what you want. But it's an easy way to do it. This is some overviews of how your subnetting could look like. For instance, on the left we have two office locations, the old one and the new one. Then within each office we have 2 floors, and then on each floor we have a few different usage types or security types. So on the other side there's 2 data centers, basically the same thing, except it's not floors but racks here. So then if you, let me first show you this. So if you then take all this, basically multiply the number of locations by the number of types, by the number of floors or racks, then you get something like, how many is this? 12 subnets in each situation. But one thing to think about is, we have these 3 things. We have the racks in the data center, there's the 2 different data centers, and we have the security stuff. So these all get numbers, and how do we order these numbers in order to create a subnet number? Well, if we put the location stuff first, then that makes everything easy for the routers. For instance, okay, this big block of address space goes to this data center, and then within the data center you further split it out. But then the trouble is that you have many firewall rules, while if you do it the other way around, you first do the security stuff and then the location stuff, you have fewer firewall rules and more routing table entries. Well, the thing is that in general, routers can handle large tables easier than firewalls. So in general, you probably want to do security stuff first and then location stuff. So let me show you what this looks like. So location first, you see I have one big route to data center 1 and another to data center 2. Of course, once I get into data center 1, I need to further split this out, but data center 2 only needs to see this one big block that goes to data center 1. And then within that, you have the different types of servers, front ends, databases, storage, and then you have the racks. And then what you see is, in this case, you get the 6 entries in the firewall table. But if you go type first, you only get 3 entries in the firewall table. Now the routers, so even the router in data center 1 needs to have 3 different routes for the subnets in data center 2. Data center 1. So this makes life a bit harder for the routers and easier for the firewalls. Okay, so we've done the subnetting. Then the question is, how do we fill in the local stuff? And basically, you want to avoid having to do this all by hand. With the subnets, we really take care of each one individually. But this, you want to be as automatic as possible. And the most automatic way to number your devices within the subnet is with stateless auto configuration. Used to be that gave you stable addresses, but with all the privacy extensions, this means that these addresses change every day or whenever a device reconnects to the network. So basically, you have no idea which device is which address, which can be problematic. But it is, if you don't care about that, it's very easy. One other thing is, because these addresses keep changing and there's no central place in the network that knows what these addresses are, it's really hard to put them in the DNS. Now, DHCP-v6 is slightly less automatic. It requires a server, which of course can go down, so that is annoying. But you can have a log of which devices, which address at which point in time. Of course, there is a slight issue with this, that Android doesn't support it. This can only really work on subnets where you don't expect any Android devices to connect. Now, the most stable addresses are manual configuration, but of course these are not automatic, or well, unless you build your own automation for this, but it's manual. So basically for stuff where you expect phones to connect, either guest stuff, or if you support as a company bring your own device, then there's probably going to be Android in there. Then you need stateless autoconfig. If you have, for instance, laptops or desktops that are managed by the IT department, then you can usually use DHCP-v6. You can of course also still use stateless autoconfig, but then you have DNS registration and address logging. That's much easier. For servers, I would suggest manual configuration, because you then don't have any dependency on all kinds of protocols that might do the wrong thing unexpectedly, especially after a software update. But that also means a lot of extra stuff. If you have servers that spin up really easily, then maybe it makes sense to do this with DHCP-v6 rather than put addresses in the configuration of those servers. But for physical servers, I would say probably manual configuration. So there's a few examples of how you could do this. For instance, what I like to do is the #1 address in every subnet, make that the default gateway address for hosts that need that, which is basically only the manual configured ones, because the other ones get this from router advertisements. A good way to manually configure addresses also use the port number of the servers as the number in the subnet, like 53 for DNS, 80 for HTTP. Sometimes you want to match the IPv4 address. Be careful with the the colons and the periods, and then arrange for your DHCP-v6 if you support DHCP-v6. So this is what it looks like. What you can see is that basically all the addresses are fairly short, except the ones from stateless auto configuration. These are these terrible, very long addresses that we expect from IPv6, but doesn't have to be that way. For your DNS servers, these are the only ones that need to go in lots of configurations and that people may actually have to type by hand. So it's important that they are short, and it's important that they never change. So one good way to do this is to give every DNS server its own subnet, its own /64. And that means if you want to move a DNS server, you just take the entire subnet. That was my microphone. My apologies. Sorry. You just reroute the whole /64 to a different location. You don't want to have that DNS server in a subnet where there's also other stuff that doesn't need to be moved at that point. Routers. Sometimes routers don't even need addresses at all because they can use link local addresses. What you can also do, which I like for routers, is EUI64 addressing. This is basically derive the subnet, the local part from the MAC address, and then you get something like this. What you see is that you have the same configuration lines on every router, but because they fill in their own MAC address, every router has a unique address. You don't have to keep track of which router has which address. So then was already mentioned that governments, they want to have a unified address plan for the entire country, basically. This is what the Dutch government brought me in for creating the Dutch government-wide IPv6 numbering plan. So all the cities, all the provinces, all the ministries, they have their own part of that big IPv6 block. The same could be useful for multinational enterprises. The interesting part here is that even though it's one big address block with a unified plan, with a unified way to look at security, they are not an ISP where the entire block is routed from one place to the internet. So every city, for instance, can buy service from their own ISP. So basically, although it is one block, it's used as PI space. And this creates a complication because that means that the security bits basically have to be above /48. So there's much more to say about this, but I don't think this is the time to do it. If you want to know more about this, I'll be happy to talk to you. So I'll be here today, and you can reach me online otherwise. There's also a contact at the NCC for governments if you are interested in this stuff. So basically, this is my story. These are links to the English and the Dutch version of an address preparing plan outline that's much longer, goes into much more detail about most of the stuff I talked about today. And below are the links on where you can find me. So that is my story. If you have any questions, I'll be happy to answer them if there's time.
There are some questions in the queue. We have 5 minutes for questions, so let me try and run through these, and if we can run through the answers quickly, let's see how many of these make sense. First question, about linked local addresses, can you explain why to not try to manage or use these yourself?
Are generated automatically, and they used to be dependent on the MAC address. So if your device gets a new MAC address, for instance, if it breaks and you replace it with a new one, or you replace the interface card, it gets a new address. But these days, with all the privacy extensions, then basically the addresses are not directly derived from a MAC address. So it's very hard to predict the linked local addresses a host is going to get and to know how long that will be around that address. Also, because they are not unique, it depends on where in the network you sit. So the same address can be used in multiple places. So if you are in place A and you connect to a linked local address, you get a totally different result if you're in place B. So they are not intended to be used, for instance, in a URL or that kind of stuff. So that is only going to give you trouble if you do that.
Next in the queue, is there a recommendation for what IPv6 addressing to use for clients in a data center environment? Example, DHCPv6, EUI64/48 ...
Well, I don't know if there is anything official somewhere. As far as I know, there isn't. So my recommendation is that for stuff that is fairly permanent, like a physical server or a set of VMs that are not going to change very often, then having manual addressing is easy because you exactly know what's going to happen and you're not dependent on MAC addresses or privacy numbers or DHCP servers. So but the downside is that the addresses go in configuration, so it's hard to change. If you want to spin up servers easily and you have no idea how many there's going to be, then it can make sense to use DHCPv6, because then the servers, they don't need to know their own address. They just go to the DHCPv6 server, get an address, and then they can announce that they are available at that address.
Yep. I think that I'm going to flag right now that I think I'm going to run out of the 5-minute Q&A window, so there will be more questions that Iljitsch will be able to answer after. I'm still going through the list linearly. Kevin has a question which could get a long or a short answer. Why should not be possible with IPv6?
Well, one of the things I live by is nothing is impossible, but some things are not. Basically, IPv6 is not designed for NAT, so all the extra stuff that makes the NAT happen isn't there in IPv6. So you are fighting an uphill battle if you are going to use NAT in IPv6.
Let me see. Next question, I think the short answer is yes. Can we advertise the same subnet from 2 data centers, same as we do in IPv4 for anycast routing?
Of course.
Yes. There's some interesting work out there on what you can do with v6 anycast. There's more fun answer. Hans asks, what is the reason to define 64 bits for the host part? This doesn't make sense, does it?
Well, it's a bit strange that it's a fixed number. That is true, but the reason why it's 64 is that because at some point the thinking was that we want to have a MAC address in there. The original status auto configuration is based on MAC addresses, and in the future MAC addresses will be 64 bits. That future came and went away again, so now they're still 48 bits. So predicting the future is hard.
So, right. All right. As I say, there are more questions in the queue that I guess Iljitsch will be able to get to offline. And thank you very much for your talk, Iljitsch.
You can also talk to me over lunch. I'll be here most of the lunch
Up
lunch
next, we should have Tori, if he can enable his webcam. There we go. Do we have this?
Good morning, everybody.
Good morning. All right, IPv6 only in the data center. Tori, the floor is yours, and you have 20 minutes.
Thank you. So I was thinking to talk a little bit about our thinking about running IPv6 and IPv6 only in the data center. Here at Red Pill Impro, we've been doing IPv6 for quite some time, like since 2008, I think we started for real. So we've got some experiences that might be valuable to you. And the first recommendation I would have is that the front ends of your server, if it's an internet-facing service, like a website or something like this, you should dual stack it, meaning whatever the end user is connecting to, whether that is like a port 80, port 443 type of thing, whatever is listening to those ports should answer on both protocols. And the reason for that is that you have right now, according to Google, I think, approximately 1/3 of users on the internet that actively prefer to use IPv6 when given the chance. And there are multiple big content providers that have done performance measurements saying that a client that has the possibility to use IPv6 and prefers to use it actually gets a measurably better performance than an IPv4 client, or a client that's forced to use IPv4 because the front end or the service doesn't offer it. So in order to serve the users the best, you'll want to enable both protocols. And of course, that's the reason why the big guys that know what they're doing, like Google and Facebook and Akamai, etc., they have all enabled dual stack precisely to ensure that their clients gets the best possible performance. So that's the front end, but that's usually a very small part of a data center infrastructure. So if you go and look up the DNS records of google.com, you'll find, I don't know, like a dozen IP addresses, but we all know that they have way more than a dozen servers that contribute to running the google.com service. And the same is true for pretty much every site on the internet. The backend is where all the fun is at. And our recommendation is based on actually trying what was the recommended approach at the time, which was dual stack. We tried that to dual stack our backends, but we found out that this is not a good approach to run a data center network, because in the backend systems talks to each other, and it doesn't really matter which IP protocol you use to make them talk to each other. You could use IPv4, you could use IPv6, you could use IPX for all that matters, as long as that's what works for you. And running dual stack means that you will have to operate two stacks in parallel. You have to tell your developers to test and develop for both protocols. You have to monitor both protocols. You have to configure both protocols. And because the backend of a public internet service is so much larger and so much more complex than the front end, this becomes very, very complex in the end. So our recommendation is that in the backend, you determine which IP protocol works the best for you, and then you stick with that choice. And I tried to illustrate this with a little drawing. And as you can see, the internet on the left is a very uniform place, seen from the content provider's perspective. And the same is the front-end zone, where you put your load balancers, for example, or web caches, or whatever is picking up when somebody dials into port 443. But the backend zone that's a much more populated place, let's say. So the icons that I have in the backend zone on the right there, doesn't really matter what they are. I just put some random icons in there. It could be a web server, storage arrays, database server, memory cache servers, application servers. Could be anything. Doesn't really matter. The point is that you end up with a lot of communication patterns between all of those boxes. So as you can see, there's a little cobweb of lines there, and I could have drawn more, and I certainly could have drawn more devices in that zone, because this is a artificially small and simple service with only, what is it, like a dozen different devices in the backend. Typical customer of ours would have hundreds or perhaps even thousands of devices, and they all speak to each other. So each of those little lines in the backend represents a communication pattern between two things in the backend. And if you want to run dual stack in the backend, that means that you actually have to double the amount of lines in the backend for possible communication patterns. And that is not something that you want to do, because it just gets too complex. So my recommendation, again, if you can't run IPv6 in the backend, run IPv4 only and stick with it. Perhaps that's not the message that I was supposed to give in this webinar, but that's my recommendation anyway. However, that said, if your service stack actually supports IPv6, your software that you run, your databases, your whatever it is, if it supports IPv6, and if you're running on open source software like Apache, Nginx, MySQL, whatever it is, chances are that it supports IPv6 just fine, and that you can make the backend work IPv6 only. So before setting up a customer or service or whatever it is in the data center, take a moment to check. Can this run IPv6 only? Does that work on a technical level? Maybe it won't, because you have some sort of software from some vendor that doesn't. But if it does, then stop and think seriously about making this backend on IPv6 only, because that has some advantages. The fact that you get to have global addresses everywhere means that you don't have to worry about NAT translation, as in the IPv4 NAT from RFC 1918 addresses to whatever public addresses they need to interact with. And when you connect to other networks, you will never ever have to worry about having used the same private addresses. And another very nice thing that we have found is that you never need to renumber your server LANs. If you put servers on a LAN, we've seen many times that a colleague running v4 in the backend said, okay, we need a /24 RC1918 for our application servers or whatever it is. That should be more than enough. Then it comes a couple of years later, maybe, saying, well, actually, the customer has been growing bigger and bigger, and now we need to actually put more application servers in than 250. And there's not enough room in our server network. Can we please expand it? And I would have to say no, because there is a network immediately after it or immediately before it, and you can't expand the net mask, so now you have to renumber. And that is a pain to do. But with the v6, you don't have to worry about that because the subnet prefixes are essentially unlimited. Another nice thing about running v6 only in the backend is that you don't have to ever use public v4 for stuff in the backend if you need to have public access to stuff direct into the backend. So if you go to the RIPE NCC today and you're lucky, then I think you might get a /24 worth of public v4 addresses. And if you decide to run v6 only, those addresses can be put to their ideal use, which is to provide connectivity to v4 only users on the internet. And of course, the final advantage that I wanted to mention is that you never ever have to worry about migrating to v6 if you start out by doing v6. Because, I mean, v6 is growing. I think that I mentioned it's around 35% now of the internet population preferring to use v6, and this has been growing with approximately 5% linearly over the last 5 years or so. So it's going up. It's going. IPv6 is not going away. It's here to stay. So, taking that into consideration, you might want to save yourself the trouble of having to migrate from an IPv6 only infrastructure, no, IPv4 only infrastructure, I'm sorry, to an IPv6 only infrastructure, even if that is 5 years down the line, 10 years down the line, because that is going to be a very painful project. So if you can, and you're deploying a new greenfield system today, then I would recommend go v6 only in the backend if you can. Then you save yourself future pain. And so to that end, we decided that, well, v6 only in the backend is a good idea. But there's also a case to be made for running v6 only in the front end. And that is, and we solved that by deploying or inventing or adapting a technology called SIIT, Stateless IP ICMP translation, for data center usage. And the idea here is that if you run v6 only in the front end as well, then you save on complexity in the front end too. For example, if you're running a load balancer then you bought load balancers from, say, F5 networks, and you're setting up a v4 only or a dual stack front end. That actually means that you have to configure 2 different virtual server objects into the system, which is more work than configure only one. But of course, you need your front end to be dual stack so that both v4 and v6 only end users can access it. But that's not strictly true. You only need it to appear dual stack. You don't really need it to be dual stack. So what this technology allows you to do is to actually run a v6 only front end and have the network, as in a network router, essentially provide a one-to-one stateless NAT mapping between a public v4 address, which you then put in the DNS record of your website or service, to an arbitrary v6 address, which then would be typically the v6-only front-end address. And this is done on layer 3. It basically maps the entire 32 bits IPv4 internet into an 96-bit, typically, IPv6 prefix. And then it maps the public front-end address as a one-to-one static mapping to a v6 front-end address. And this can be deployed anywhere in the internet or in the network. Since basically that /96 IPv6 prefix is routed to the translation function, and the public v4 address is routed to the translation function, it could be anywhere. It could be on the other side of the internet, and it still works the same. So this is something that we made, I don't know, 5 years ago or something like this. It's an RFC. I don't recall the number it's at the moment, but I'm sure Google can help with that. That has been made available in both software implementations, such as Joule from NIC Mexico, and from in the hardware implementations as well, such as the Cisco ASR series, at least, probably others. I'm going to just walk through how it works and for the rest of my time. And this is kind of the packet flow. So let's say we have a IPv4 client over here. Let's see. This is the IPv4 client. He has public IPv4 address something something out on the internet. And when he wants to make a request to the web server or the load balancer in front of the web server, whatever it is, which is here, he'll send an IP packet with his source IP, of course, and the destination IP, which is in DNS, and then a standard HTTP request. Now, the trick is that this destination IP here is routed to these SIIT border relays. And of course, I drew 3 of them here, so to illustrate that they can be many of them. They can be load balanced with any equal cost, any cost routing, multipath routing, sorry, because they're stateless. They only do this packet by packet. And once this packet here reaches the translator, it changes it to IPv6 by prepending this translation prefix and swapping the original destination address for the actual IPv6 only destination address. And now this is just a standard IPv6 packet. So this gets routed to the front end. It's a standard IPv6 packet. So there's no magic after this translation happening. The front end will see this as just a regular protocol compliant packet, and it will respond to it normally, swapping source and destination IPs, swapping source and destination ports, and including a response. And then this prefix, the 64FF9B prefix, is then routed in its entirety back to the translation function. And that one does the translations in reverse, basically by stripping out the prefix and doing the inverse swap of the source v6 address to source v4 address. And this just goes back to the client as a regular v4 packet, which has no idea that this was just this was translated to v6 and translated back in the response, because it thinks it's talking to a v4 server, whereas the v6 front end thinks that it's talking to a v6 client. And that's all there is to it. It's meant to be super simple and easy to understand and easy to deploy. As a matter of fact, this particular setup only takes 2 config lines on the dual open source translator. It's basically set up this prefix for translating the IPv4 internet, plus this one-to-one mapping. That is all. And this allows us to, or allows me on the network team to tell my colleagues, which are working on managed services and the cloud operations, saying, okay, you just make v6 work, and I'll give you a v4 personality for your v6-only service that you can put in DNS. And it works. We have it in production for several customers and no complaints. So we're happy about it. Anyway, that was it for my presentation. So is there any questions and time for questions? Let's hear. Thank you.
We have 4 questions in the queue. As before, I'll go through them linearly. So first up, could the v4 or v6 only backend recommendation be a major reason that so many content providers are v4 only? What arguments can we prevent? What arguments can we prevent them to switch to v6? What arguments do we have to get them to choose v6 over v4?
Well, I think personally that the performance argument is a heavy one. Where if you can demonstrate that your website loads, I think it was like around 15%, I think Facebook measured, that their site, when everything else is equal, a client that is permitted to use v6 loads it around 15% faster than a v4 over v4. And that is significant because users expect things to load quickly. If you have 2 competing sites and one is 15% faster than the other, then that is a competitive advantage. So I think that is perhaps something that will, as in when this gets more and more true, and perhaps that 15% is increasing to 20 or 25 as v4 is getting more and more overloaded, and as ISPs are deploying more and more v6, I think that is kind of the killer argument, at least right now.
Yep. Kevin asks, given that an IPv6 migration is painful, is it worth migrating the backend from IPv4?
Perhaps not. If it works for you and you have no grow pains with v4, then I personally wouldn't bother, as in I wouldn't push that on a customer which has a v4 backend that works fine. I mean, from a data center operations perspective, you want stability over anything else. And if it ain't broken, don't fix it. Because like I said, if you have dual stacked your front end or made your front end appear dual stacked, then there's not really any upside in itself to run v6. Obviously, if you have issues with running out of private IPv4 addresses, which some providers do because 16 million addresses is just not enough, then clearly you might have a case, but you will probably know that when you see it.
So I'm going to move quickly here because we're running out of time. Jan is asking, which open source implementation of SIIT would you recommend?
One that's called Jewel, which is Juliet Oscar Lima. It's made by Nick Mexico and the University of Monterrey, I believe, in collaboration. It's on jewel.mx or GitHub something. You'll find it. It's a Linux kernel module.
Somebody's already pasted the link.
Right. And yeah, it's very easy to set up. there's also a possibility that it can be done with something called BPP, which is a Cisco or Linux Foundation project, which is perhaps more high performing because it runs in user space as a polling using the DPDK polling drivers. But I haven't tested that myself, so I'm not. I don't want to recommend it.
Got it. Christian is asking, do you think that this works in a VM ESX environment with 10 gig per second networking?
I don't see why not, because these translations are done packet by packet. So there's no NAT table, session table, binding tables. There's none of that. So if your VM, of course, it depends on the specification of the VM, but if your VM can push 10 gigabits of routed traffic, yes, regular V6 to V6 or V4 to V4 routing, then it is quite likely that it will also do 10 gigs of V6 to V4 routing based on it, because it is packet by packet processing. It's no state.
Yep. Pardon me. Thank you, Tori, for your presentation.
Thank you.
Interesting stuff. There are a couple more questions in the queue. I think that we will get those to you by email, and/or you can answer people directly in the chat. And we have one more talk in this session from Pete Stevens. If Pete can enable his webcam, then we'll get him going. Pete, are you there? We have slides, but maybe not a Pete. Pete has lost. There we go. Do we have... Are you there? I cannot hear.
Hello? Is that better?
There we go. That's better. Cool. All right. Pete is going to be talking about managing IPv6 services.
IPv6 only in the data center.
Yeah.
First question, why? Why would you ever do it? And that's pretty easy. Raspberry Pi make computers that cost $5 and an IP address costs $24. So computers are cheaper than IP addresses. So at some point, we need to work out how we're going to network all of these computers without IPv4 addresses. So that was my kind of starting motivation. So moving forwards, this means I need to assume that I'm going to sell services that don't have public IPv4 addresses. So is there any sellable service that we can deliver as a company without consuming a v4 address for taking on a new customer? And thanks to a bit of a cock-up in 2012, we'd accidentally prototyped this. So back in 2012, Raspberry Pi had just launched their main website, and just after Raspberry Pi went live, most of the teenagers in the world decided that sending a DDoS consisting of SYN packets was a really fun thing to do. So what we did was we dropped some small servers in front of Raspberry Pi to sync the SYN packets and then proxy on the actual useful web traffic to the back end. And at this point we were dual stack. So we used IPv6 to communicate from those proxy servers at the front to the back end server. However, some of the kids still knew the v4 address of the back end server and were going to it directly, even though it was no longer in DNS. So we worked around this by just switching v4 off on the backend server, because you can't DDoS something that you can't route to. And that worked really well. Remember, in 2012, v6 was less than 1% of the internet traffic. Today, this strategy does not work so well, because 30% of your inbound traffic comes over v6, and you can easily DDoS things over v6 these days. So This gives us something that looks like a bare minimum of a service. So we have a virtual machine or a server that's only got v6 addressing on it. Inbound traffic comes in through a dual stack load balancer or a dual stack proxy service which forwards connections on. HTTP works absolutely fine. HTTP load balancers are well understood and easily available, so that's not a problem. HTTPS was the sticking point because you need to forward to the backend with the SSL certificate or put all of your SSL into your load balancers. So we didn't really want to do that because we didn't want to have our front-end load balancers containing the private keys for every customer behind. But SSL supports something called server name initiation, SNI. And this means that the very first line of the connection says which domain name it's trying to connect to, and you can use that to forward to the correct backend. The reason this hadn't been done before, and the reason people still seem to believe that you need an IPv4 address to have an SSL certificate, is IE6 on Windows XP doesn't work with SNI. However, that went end of life without security updates in 2014. So we took a decision to stop caring about that. So if someone with Windows XP goes to an SSL-enabled service behind our proxy service, they will get a certificate failure that says your connection is not secure. They're running an operating system that's not had security updates for 6 years, so it isn't secure. That message is true. Admittedly, the reasoning of why it's not secure isn't quite right, but I don't care about sending security failures to Windows XP users. That's all right. The other thing, of course, is not all traffic to web servers comes inbound. Some of it goes outbound. Occasionally, the web servers need to go and fetch resources from somewhere else. So we have to call out to other users and other services that don't have IPv6. In particular, Twitter and GitHub are two particular favorites for embedding tweet streams and downloading your source code. Now, again, there's a solution to this, NAT64 plus DNS64. So DNS64 is great. What happens here is when you try and connect, you do a DNS lookup for an IPv4 only resource, the DNS server lies and gives you a v6 address back. This v6 address points at a NAT64 service, which receives the packet inbound and then forwards on a v4 connection to the actual resource you're trying to get to, and then gives you the data back. So this will quite happily forward TCP connections to any v4 service you need from any v6 only server. So we run a central NAT64 and DNS64 service for servers on our LAN. And this works fine for straightforward web applications. We can fetch data from the Twitter APIs, we can download your files from GitHub, you can access SSH on GitHub, and this gives us a minimum viable product that we can actually go and sell to people. So, a little bit of extension. What other protocols will this support without doing too much work? So POP3AS, IMAP, Secure IMAP, Secure Mail, they work fine because SSL again uses SNI so it can find the right backend service, so we can forward those onto your backend server. Unencrypted POP3 and unencrypted IMAP, we can't proxy, they won't work. But that's okay because nobody should be using insecure email protocols these days. So, you know, SSL has been available for a long time. Let's Encrypt has made it free for a long time. We just take the view that we don't support unencrypted POP3 or unencrypted IMAP on our v6 only servers. The more difficult one is SSH, which we can't proxy either because SSH doesn't use SSL for the connectivity. We've worked around this by we automatically configure a port forward on a v4 capable machine that can then port forward onto your v6 only server. Or you tell the administrator of the VM or the server that you've got that they should enable v6 to get to the administration interface. And that's a much easier sell than telling people they have to have all of their customers use v6. Because a lot of these smaller servers only have a handful of people who use it. And certainly in the UK where I am, multiple large ISPs have native v6 support. So you can just say, here are a list of IPs with working v6 support. If you use those, your life will be easier. Don't use the other ones. Which also has the nice side effect of providing a little bit of commercial pressure to encourage people to migrate. And the other thing here is any SSL protocol is fairly easily proxied, which is good because everything should run SSL. We should try and turn off every protocol that isn't running SSL, in my personal opinion. So that's all good. Ben Nuttall is a very keen user of our v6-only services, and has had v6 natively in so many places for so long that he discovered at a hotel he couldn't administer his servers because he'd forgotten he has v6 all over the place. Yeah, he would really like a little button on booking.com or Airbnb that says network includes v6 to make his life easier when traveling. How does this flow into our wider business? Well, most of Mythic Beast's business is actually managed virtual machines. That's the biggest chunk of what we do. Manage virtual machines, manage dedicated servers. This makes it easy to roll IPv6 only because we're controlling all the configuration on the server. So the customer doesn't necessarily need to understand or even know that you've rolled v6 and you're using v6 for all sorts of things. But it does mean that our entire management stack has to work with a v6 only host. And when we started this, obviously we had a management stack that worked with our v4 hosts, which is where we were. Monitoring and graphing is one of the core things we do. We had to fix up our user interface to allow you to put v6 literals in, because v6 literals have colons and square brackets, whereas v4 literals have dots in. So that wasn't too bad. We need to make sure we always prefer connecting to servers with v6 if it has an allocated v6 address, and that means telling our database about all the v6 addresses we've allocated. And there was a little bit of cleverness, which is our dual stack servers may report in over v4 or v6. So you need to make sure that when you get reports in from those, you can match it up to the machine, which is just a generalization of the problem that machines can have multiple IPs and might use multiple source addresses. But that wasn't too bad. Backups worked out of the box on all of our v6 servers. That was dead easy, everything just worked. But that was because we had a NAT64 proxy, which was obviously proxying all the traffic to our v4 only backup server. This was quite easy to spot because our NAT64 service saw some very large and very impressive traffic spikes. On balance, adding a native v6 address to our backup servers and putting it in DNS improved things greatly, so all the backups go direct over v6 and don't get proxied. One trivial fix to make your life much easier. Security turns up. People start talking about security very quickly and often have very boring forms for you to fill in. IPv6 only security is exactly the same as v4 only security. You've got a network protocol, you need to secure it, you need to know what ports are listening, you need to know what applications are listening. Getting and deploying updates for your virtual servers is fine because nearly all of the mirror servers these days have v6 on them. And in the off chance you hit a v4 only mirror server, the NAT64 proxy deals with it for you. Upgrading your application is fine as well. The NAT64 proxy deals with GitHub for you. But v6 reduces your workload because now you only have one firewall to configure on your server, whereas a dual stack server has two firewalls to configure. So we've effectively skipped or already paid our technical debt for the v4 to v6 transition. And that's already done. The one thing that does turn up is occasionally companies will go and get an external penetration tester who wants to come and probe your network from the outside. And their first question is, can you give me all of your IP addresses and whitelist traffic from all of our scanning servers? So you give them a bunch of v6 addresses and they go, what's that? And then they demand to see the v4 addresses you're using. And if you give them localhost, you get some nice entertaining answers. Depending on whether they don't realize that it's localhost or whether they think you're, just messing them about. But that all works fine. It's easier. v6 only is easier than dual stack, and that's why we like it. Flipping back in time to before we had quite so common v6, and we had customers running RFC 1918 space behind their internal firewalls. This means that when we want to automatically apply a patch to a customer firewall, we need to SSH into it and apply the update. And that means our jump box that our staff members use to log into the managed customer server behind their firewall needs to have some mapping to get it through and some tunneling. And this is easy because obviously every one of these customers has a unique RFC 1918 space, so we can just have a mapping of how to get in. This, of course, doesn't work at all. Almost all the customers have used 10.0.0.1. So we're in the position that we receive a support ticket from a customer that says our server 10.0.0.1, and we have to go and look up a custom mapping in order to work out how to get to their back end. With IPv6, this is dead easy. Every single customer server behind their firewall or not has a globally unique address. And then in the firewall, you just need to add an allow rule. So my jump box can log into your backend server. We don't need port address translation. We don't need to have custom mappings. SSH can just remain on port 22 on all servers, and we can assume it stays there. And this separates routing and firewalling. So we have some routers that worry about where our addresses go, and then we have some firewalls that worry about who is allowed to connect to what. And those two things are separate and can be managed and administered by different people, which undoes a large chunk of the pain of working with network address translation in v4, where if you want to open up an inbound connection, that involves effectively changing your routing and your firewalling and lying about where the service is in the first place to the wider internet. So this is good. It means you have less work to do if you are running a v6 only setup. New management services. Any new managed service we roll out will support v6. It might support v4, but it doesn't have to. We don't need v4 on any new management services we introduce. And if an existing customer of ours who's currently still v4 only wants to use a new management service, we can enable that by having them turn on v6. That is the right way to solve this problem. We don't need to build new technical debt to support customers that haven't paid off their own technical debt. So do we actually have any customers? So we've got some obvious technical ones. We run the website for London Internet Exchange. That's a WordPress-based site on some v6 only VMs. Raspberry Pi has some forums, some WordPress sites, and so on, and quite a few internal things that are all running on v6 only VMs, all hidden behind dual stack proxies. UK Network Operator Forum, their conference booking system, wiki, documentation, and things like that are all running v6 only. But they're all networking professionals or technology professionals. You'd expect them to be up to date. I'm kind of more pleased with the less obvious ones. Parallax Photographic, they make a camera film. They sell gigantic chemistry sets where you can put them into these strange devices that light comes in and pictures come out the back. Used to be popular about 30 years ago. So completely retro company. They're v6 only. Weather for ECMF, and Alexis do I/O profiling for various bits and pieces. So that's all v6 only, all works fine. So the other nice bit, the Raspberry Pi rack. We built rack mount Raspberry Pis. That is our original build, which is Raspberry Pi 3 with power over Ethernet hats. This means you have one wire to each Raspberry Pi. In 4U of rack space, including the switches, you get 108 Raspberry Pi 3s, which gives you 432 cores in 4U of space. Not very fast cores, but with the advent of Raspberry Pi 4, which we'll have very shortly, they are now much more exciting machines. About 3 watts a server, so this is a comparable server power density to traditional 2U servers. Our original plan was we'd give them all a /30 of RFC 1918 space so they can have a network file system because their bootloader is v4 only, and then we provide a public v4 and a public v6 address on a tagged VLAN. This is a great idea apart from the fact that it doesn't work. There is a bug in the boot ROM on the Pi 3. If it sees a packet from a tagged LAN during the boot up, it crashes, and computers that don't boot are very hard to sell. You can fix this by giving them a /30 of space. But then we're using $96 of IP space to turn on a $35 computer, which is crazy. Whereas we could just give them each their own 64 and give them their own rooted VLAN. So v4 for Pi 3 is way too expensive. We could try and cheat with proxy ARP or /31, but it's all horrid. And this is really an educational platform, so we kind of want to teach people to do things right rather than teach them to do things badly. So we decided that we were just going to make it v6 only. We don't support v4 at all. Our Pi Cloud does not support v4. We automatically configure some proxies, so you get a port forward for SSH on a given port number, and we automatically configure a HTTP and HTTPS web forwarder because most people host websites. And then the root of your domain, your hosted pi.com address, is the v6 only address if you want to talk directly to the backend Pi. Yeah, it's an experimental platform. It doesn't have an SLA, but the Cambridge Beer Festival used it for managing how popular all the beers were. Ben Nuttall runs PyWheels, which automatically builds Python packages for ARM CPUs, and this builds basically for the Raspberry Pi project, and it natively builds everything on ARM. We've got lots of Pi users who are running their websites and their meeting pages. And the biggest problem we have with this platform is people read the How to Secure My Server guide and they firewall everything in IPv4, and the only thing they can see in IPv4 is their file system, and your computer does not work well if you firewall out your file system. So PyWheels is quite a little computer, and it's shipped 20 million binary downloads from one Raspberry Pi through our proxy server, and is kind of a key part of the Python on Raspberry Pi infrastructure, which is what they're using to teach 25 million people to learn how to program. So it's just one Pi 3, 4 not very quick cores, a gig of RAM, 100 meg Ethernet, currently does 40,000 downloads per day from that little server. So yeah, it works quite well. And we now have the slightly less little computer coming up, the Raspberry Pi 4, now available with 8 gig of RAM. When we launched the Raspberry Pi 4, we actually moved the entire Pi main website to the Raspberry Pi 4. Our cluster of 14 4 gig Pi 4s did 10 million visitors, and again, everything v6 only. It was a v6 content origin that went to the CDN that finally delivered the v4 at the end. But from the point of view of our network, we didn't use any v6 addresses for the whole launch. So there's now an 8 gig model, and hopefully very soon we should have that available. So how do you get started? It's pretty easy. Bring up a v6, bring up a little VM with no v4 address, and turn on your web server. Pick a CDN of your choice that supports a v6 origin. And then you can set your name servers to be NAT64, DNS64, and some of those, that's a NAT64.net runs a public NAT64 service. And congratulations, you finished. You now have a v6 only VM that's providing a dual stack service to the public. So, oh, hang on, I appear to have gone backwards. Ah, I have one extra slide at the end that wasn't supposed to be there. That was supposed to say, thanks very much for listening, and do you have any questions?
Thank you, Pete. We have 2 questions in the queue, and we are already 1 minute into the lunch break, so I will take these. Somebody called Fu has asked, SSH has proxy jump and proxy command, why not use those directives or use forced command and netcat to v6 from v4?
We have to explain that to every user who wants to connect through it. It's much easier to give them a port number and minimize the support load. Fair.
And Manuel has a question, which sounds to me like a very general question. Maybe I missed a section in your talk. Automatic configuration based on Slack in v6 has potential vulnerabilities. How can you resolve the exposure of MAC addresses that can allow host identification through the IID, NIC provider, or host provider?
We statically configure v6 addresses with cloud config.
There you go. And that's it. That's all that we have in the queue. Thank you for your talk. Thank you for all of your talks. And that's us for our IPv6-Only data centers session. You're now free, of course, to step away and take some lunch, and we'll be starting back around about 1 p.m. with IPv6-Only in ISPs and enterprises. Thank you, everybody.